Translating a human sentence like, order 2 grande hot oat milk lattes with light vanilla syrup into a priced, persisted database order is a massive translation challenge. Human language is chaotic. Software databases demand strict, structured coordinates. Back in 2023, developers tried to bridge this gap by forcing the AI to behave through a parallel translation pipeline. They manually mapped every product, size, and temperature from their real database into a custom TypeScript schema. Then they generated specific prompt instructions and hand-coded retry loops to correct the AI when it inevitably output the wrong JSON shape. This forced developers to maintain 2 separate sources of truth. If the coffee shop updated the price of oat milk or added a new syrup in the real database, the isolated AI schema instantly broke. But as language models advanced, those hard-coded retry loops and rigid prompt scaffolding became unnecessary. The models grew smart enough to make those routing decisions on their own, meaning the handwritten guardrails were actually restricting the AI's potential. Instead of forcing an AI to memorize a fragile, custom-built replica of an application, the solution is to expose the actual APIs directly and let the model organically discover what is available. ServiceStack API Tools does exactly this. Your existing typed APIs, validation rules, and server metadata automatically become native tools that any AI can understand and use. Instead of dumping hundreds of endpoints into a single prompt, the AI navigates the live application through a 3-step progressive discovery loop: index, context, and action. First is the index phase. The model calls API search to query the live application, actively finding only the endpoints relevant to the user's specific intent. This prevents overloading the AI's context window. Second is the context phase. The model calls API describe. This raw JSON schema block on the right is pulled directly from the API, defining the exact data contract the AI must follow. The model reads this to learn the required parameters, valid sizes, and live prices on the fly, without prompt injection. Because they share the identical source of truth, this same schema automatically generates the HTML input form on the left. Third is the action phase. The model uses API call to formulate a properly typed request using those precise discovered rules. Throughout this execution, the AI operates entirely within the boundaries of the authenticated user. It accesses the same service gateway and respects all existing security roles, claims, and permissions. This log shows the sequence in real time. The AI calls search to find the tools, describe to learn the menu structure, and call to place the order, exactly in order. The model is no longer executing a rigid script. It operates as an autonomous user, actively reading and applying the application's living documentation. Letting an AI autonomously browse a menu is safe, but giving it unsupervised access to write to a database or charge a credit card introduces severe security risks. To prevent unwanted operations, every destructive or write action is guarded by a 2-phase confirmation token. While read actions execute instantly, write actions automatically pause the workflow. This generated approval form presents the itemized order details, forcing the user to review the data and explicitly hit the Confirm and Execute button. Once confirmed, the backend cryptographically validates the token. It checks the user identity, target API, and payload argument hash, guaranteeing the AI hasn't altered the data before touching the database. This confirmation token successfully merges the convenience of a natural language chat interface with the strict, deterministic security boundaries required by enterprise software. Because the AI relies entirely on the application's real APIs, the single source of truth is perfectly preserved. There is no AI-specific business logic written on the backend. This decoupling aligns perfectly with the Model Context Protocol, or MCP. MCP creates a universal standard for connecting AI assistants to backend servers over HTTP. This terminal interface shows Claude executing the exact same backend workflow. You can clearly see the priced order summary and the 5-minute expiration warning for the confirmation token. And this interface shows OpenAI's Codex app running the identical API sequence, arriving at the exact same $10 total and returning the unique order confirmation number. Because the protocol is completely model agnostic, this log shows an open-source model, DeepSeek Flash, utilizing the identical tools and step-by-step calls to place the exact same order. By combining MCP with native metadata, developers avoid building brittle wrappers. They upgrade their existing, well-validated APIs into universal capabilities that any future AI agent can instantly understand and safely execute.